Hello.
Good evening, ma'am.
Yeah, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay, so this is
Good evening,
Prerna
ma'am.
Gupta, your new questions chapter. Today's session will be the doubt session of week 11. So before I start taking your doubts, let's take a quick recap of what you have studied in week 11. So first of all, you studied Bernoulli's dial. So what is the Bernoulli's dial? Anyone?
Only two outcomes, either success or failure.
Yeah. So so in a Bernoulli trial, the outcomes can be categorized in two categories. Either it will be a failure or it will be a success. Then we have studied binomial distribution. So what is the PMF of binomial distribution? Tell me. Okay, the binomial distribution, it is NCX p to the power x 1 minus p to the power n minus x, where p is the probability of success and n is the total number of trials. Now tell me what is the expectation of binomial variable?
Screen is not visible.
Oh, okay, okay. Yeah, is it visible now?
Yeah, thank you.
Yeah, sorry for the inconvenience. Okay, so now tell me what is the expectation of a binomial random variable?
NP.
Yeah, it is MP. And variance? So
Bx
variance
square
is,
NP
minus
into 1 minus P.
yeah, NP
1.
into 1 minus P. And what X represents here? X represents the number of success in N independent trials. Okay. Now then you have studied M is of one type and remaining capital M is minus small without replacement. Okay. So the PMF is small m, C, small x, capital N minus small m, C, small n minus x, capital N, C, small n. Now, what is the expectation? Yeah, anyone? It is small n into small n divided by capital N. And what is the variance? Okay, variance is small n into small n divided by capital N, 1 minus small m upon capital N, from capital N minus small n divided by capital N minus 1. Okay. Then Poisson distribution. So the PMF of Poisson distribution is? Yeah, could you tell me? It is e to the power minus lambda, lambda to the power x divided by x factorial. And x goes from 0, 1 to up to infinity. What is the expectation of x here?
Lambda.
Yeah. And variance of x?
It is also lambda.
This is also lambda. Yeah. Fine. Okay, so we will start by the activity question first. Okay. So any doubts on activity 11.1? Hello.
Fine.
So no doubt from activity 11.1. So from activity 11.2, any doubt?
First problem, ma'am.
First problem.
Problems.
Yes, ma'am.
So the question is x is following binomial n comma p and x is the following CDF. Now we have to find out the value of n. Anyone has solved? Hello.
Yes, ma'am.
Yeah. Audible now?
Yes, ma'am. Now we
Okay.
can hear you.
Okay, okay. Yeah. I think there is some network problem. Yeah, I was asking, anybody else has solved this question? No one? Okay, let me tell you then. So here it is given that for f0, the value is 1024. Okay, from the CDF you can see if you put x equals to 0 here, then it is 1024 divided by 3125. And the value of f1 CDF at the point 1, it is 2304 divided by 3125. So in this way, value of f5, it is given as 1. Okay. So it is given that f5 is equal to 1. So what you can interpret from it, that x can take maximum value 5. Okay. So the answer will be 5. Got it or no? Hello.
Yeah, ma'am.
Below 0 is 0.
What f of x represent? F of x is probability of x less than or equal to 5. Sorry, less than or equals to x. Okay. And here we are given that fx is equal to 1 when x is greater than or equal to 5. So what you can interpret from this? Probability x is less than or equal to 5, it is given as 1. So what you can say that x can take maximum value. So x will start taking the value from 0. It will take 0, 1, 2, and will go up to 5 only. Okay, it cannot take a value beyond 5 because at this point the CDF is 1. So the maximum value the x can take is 5. Okay, so answer will be 5. Value of n will be 5. 5. Got it or no?
It's coming 6, right?
Value of n 6.
0, 1, 2, 3, 4, 5, 6.
No. It will be 0, 1, 2, 3, 4, 5 only, not 6.
Including 0, it is coming 6 number 0, 1, 2, 3, 4, 5.
No. You don't have to count the numbers.
Yes,
See,
ma'am.
just a minute. What is the range of binomial distribution? It is x equals to 0, 1, 2, up to n. You don't have to count like 0, so it is 1, 2, 3. It's not like that. It is 0, 1, 2, up to going up to n. So you have to find this number.
Okay, ma'am. Okay.
Okay, so this is 5.
We will count from
Okay,
0
got it.
onwards.
No, you don't have to count these numbers. You just have to take this value.
0 is not a part of a sample space.
X is taking value from 0. Okay, but here we are asked the value of n, not the number of the values that x is taking. Okay.
Okay, they're asking n. Okay,
Okay, it
not
is
x
asking
value.
n. Okay.
Okay.
Okay, so value of n will be 5. Any other question? From this
You can
activity?
solve this everything.
From any other activity? Activity 11.3?
Same question, having 3 questions, right?
Okay, so all the parts you're asking.
Yeah.
Yes, sir.
Okay, now value is p. Okay. So CDF is given. We have already find out the value of n, which is 5. Now we have to find out the value of p. Okay. So n is given 5. Now we know that fx is probability x is less than equal to x. So we are given f0. So what will be f0? It will be probability x is less than or equal to 0. Okay. We can write it like x equals to 0 plus probability x less than 0. Now from the question, we can see these values. So when x is less than 0, value of CDF is 0. And when the value of f0 is 1024 divided by 3125, right? Right or not? So it will be 0
Yes, ma'am.
and it is 1024 divided by 3125. Okay. Now we know the formula of f0. We have to add these two values. So when the x is equal to 0 and when x is less than 0. So x is less than 0 is not possible, because random variable takes value from 0. So the value of f0, the CDF at point 0, it will be n, c, 0, p to the power 0, 1 minus p to the power n minus 0. And we have already calculated this value as 1024 divided by 3125. Okay, n is given as 5. Now 5 is 0. We have to calculate the value of p. So p to the power 0 will be 1. Now 1 minus p to the power n minus 0, which will be 5. Now you can solve this equation and find out the value of p. So solve it now and tell me the value.
It's 4 by 5.
1 minus p will be equal to 4 by 5. Okay. So p will be 1 minus 4 by 5 equal to 1 by 5, which is equal to 0.2. Got it?
Yes, ma'am.
Okay.
So P value is the first value, 0 to 1.
What?
The P value means the first value takes 0 to 1, right?
Probability of
P is
success.
representing the probability of success.
Okay.
What you are asking?
So instead of 0, NC0, we can plot any other number also. NC1 equal to the same equation.
You can use any value. You can use F0 also, or you can take any other CDF at any other point also. I have used F0 here.
Okay.
Okay. Yeah. Now the value of Q, what will be the value of Q now? Tell me.
1 minus
Yeah, 1 minus Q.
0.8.
We know that
Yes.
in binomial distribution, P plus Q is equal to 1. So you can find out the value of Q now. Okay.
Okay.
Question number 4 also, or you have solved it?
First we add from 0 to 3.
Yeah. We have to add the probabilities at 3, 4, and 5 because the value of n is 5.
Okay, okay. 3 to 5.
Yeah, 3 to 5. Any other question in this activity?
This is fine.
Okay. So from activity 11.3. Any questions on this? No? So have you all solved all the questions?
Third question, ma'am. The company is planning.
Third question. Okay. The third question is, a company is planning on expanding its reach. It is planning to open at least 2 more branches in the city and is considering 4 different locations for it. The probability of successful opening of a branch at a location is 0.65, and the success of branches are independent of each other. So from the question, you can see that it is an example of binomial distribution, right? Because you can see that the
Yes.
probability of successful opening for each branch is given same, is 0.65 only. And the trials are also independent. So it will be the example of binomial distribution. Okay, now we have to find out the value of the parameters we use in the binomial distribution, which are n and p. Okay. So
Okay.
read the question again. Can anyone tell what is the value of n and p here?
N is 4.
Yeah. Yes,
P is 0.65.
yes. Is it clear to everyone?
Ma'am, we are trying to search for P of x equal to 2.
Okay, okay. So what is the problem in this question? Probability of x is equal to, you have to find.
Yeah.
What is the formula of probability of x is equals to x for binomial distribution? It is NCx
NCX.
p to the power x,
Yeah.
1 minus p to the power n minus x. Okay, now you know the value of n, which is 4. You know the value of p, which is 0.65. Okay, and value of x, it is given as 2. So you just have to put all these value in this formula and calculate the value.
Got it.
Okay, any doubt in this question?
No.
Now, what is the next question? Next doubt.
Question 5.
Question 5. So question 5 is, suppose that 4.5% of people living in a particular city own a Creta. A survey has been conducted to know what brand of cars people use in the city. What is the probability that the 12% being interviewed during the survey is the second one to own a Creta? So it is given that the 12% being interviewed is the second one. So from this statement, we can conclude that in the first 11 people, there will be one people exactly who is having a Creta, right? Right or no?
Yes.
Right.
Okay. So the probability which is asked here, final probability will be equal to the probability that exactly one Creta owner among the first 11 people. Which we have interviewed, multiplied by probability that 12% owns a Creta. Fine.
Fine.
So now we have to calculate these two probabilities. So in the first part, we have to find out that out of the 11 people, there will be exactly one people who is having a Creta. So you can use binomial distribution here. So out of 11, only one people is there. P to the power will be 1, then 1 minus p to the power 11 minus 1 will be 10. Okay, into, from the question you can see, it is given that the 4.5% of the people living in the particular city owns a Creta. So 12% is having a Creta. It will also be 0.05. Sorry, 0.045. Right? And value of P is also 0.045. Because it is given that the probability of having a Creta is 0.045. So P will be this. Now you know all the values, so solve it.
Got it.
Got it? Now you solve this and you will get the answer. Okay, so any other question from this activity? No? So 11.4. Any question from this? 11.5. 11.6. 11.7. 11.8. 11.9. 11.10. 11.11. 11.12. 11.13. 11.14. 11.15. 11.16. 11.17. 11.18. 11.19. 11.20. 11.21. 11.22. 11.23. 11.24. 11.25. 11.26. 11.27. 11.28. 11.29. 11.30. 11.31. 11.32. 11.33. 11.34. 11.35. 11.36. 11.37. 11.38. 11.39. 11.40. 11.41. 11.42. 11.43. 11.44. 11.45. 11.46. 11.47. 11.48. 11.49. 11.50. 11.51. 11.52. 11.53. 11.54. 11.55. 11.56. 11.57. 11.58. 11.59. 11.60. 11.61. 11.62. 11.63. 11.64. 11.65. 11.66. 11.67. 11.68. 11.69. 11.70. 11.71. 11.72. 11.73. 11.74. 11.75. 11.76. 11.77. 11.78. 11.79. 11.80.
Yeah, the first
Question
question.
number 4.
First question.
Yes.
Okay, so here you have to find value of n. Statement is consider a string of length 4, a sequence of 4 bits, where each bit can be either 0 or 1. Suppose you want to transmit 4 bits wirelessly via a transmission channel. The channel is noisy, that is, there is a possibility of error. Assume that changing a bit at the I place is independent from changing the bit at the j place. I is not equal to j. The probability of one bit getting changed is given to be 0.1. So let the random variable x denote the number of bits that changed. So basically, we have to find the value that x will be taking. So here x is representing the number of bits changed, and we are given the 4 bits. So x will be taking values 0, 1, 2, 3, 4,
Yes.
right? So what will be the value of n?
4.
4? Yeah,
4.
yeah, 4. A value of p is also given here. The probability of one bit getting changed is given to be
0.1.
0.1. So value of p will be 0.1, right?
Yeah, okay.
Okay. So next out,
Question number 4.
I have
question
a
number 4.
question.
Yeah, ask.
Are we expected to remember the formula for skewness?
Formula of skewness.
Yeah.
There
is one question which I come across where the binomial coefficients are given and asked whether it is a left skew or right skew.
Okay, tell me the question, then I will explain.
Ma'am, this assignment question number 4. Assignment activity 11.4 का question number 4.
Yeah, I will tell you this also. The question regarding the skewness, where it is?
It's
What question?
the last one. 1 minute.
Which activity?
11.3.
11.9,
11.3.
11.3.
Yeah, 11.3. Question number 2.
Okay, see. For binomial distribution, so there is a simple trick from which you can find out whether the distribution is skewed or symmetric. For
Okay.
binomial distribution, if value of p is less than 0.5, there are 3 cases.
Okay. That's known.
Okay. So in this case, it will be positively skewed
That's
or right skewed.
less than half is left or right. I don't know.
What?
So, no, less than, this is less than half. Probably
Yeah,
it is less
less.
than half. Do we call this a left-hand side?
No, no, we will call it as right,
Okay.
not left. Okay, don't get confused here.
Ma'am, how
And-
can we say it is right? Ma'am, can you please explain
Okay,
that?
okay. The graph of positively skewed is something like this. Yeah, you may ask that it should be left because the figure is on the left side, but it is not
Yeah,
like
the word
yeah,
play is a
yeah,
confusion. We know
yeah.
whether it
I
is.
understand this. It can be a confusion, but you can remember it like if positive, then right, and if negative,
Okay.
then left. Okay.
So like we can remember if the tails goes the right.
No. In
Yes.
positive skew, it will be
Positive score if the tail of the graph goes
is
the right side.
yeah, tail will be at the right side.
Right side.
Yeah.
The negative skewed, you can say
Hmm.
tail will be on the left side.
Yeah.
And then symmetry. That's it.
Yes. Okay. Now clear? So these are the conditions. And apart from this, if the value of n is very large, then the distribution will be symmetric only.
It is 10 to symmetric.
Yeah, it is 10 to be symmetric. If the value of n is very large, in that case only. So these are the key points.
So we don't have to calculate the skewedness, right?
Yeah, you don't need to calculate it actually.
Since I was confused whether you need to know or not, that's why I asked.
From this formula, you can find it out.
What about P?
Fine.
If n is very large,
What?
if n is very large, then what about P? It's small or large number?
If n is very large, then regardless of the value of p, the distribution will be symmetric. It doesn't matter then if p is very large or small. If small n is very large, then the distribution tends to be symmetric. You can take an example and draw the graph of the PMF, and then you can see how the graph is behaving for the different values of p and different values of n. Right?
You got it.
Okay. Yes. Someone was asking the question. 4, right?
Yeah, ma'am.
So question is, what is the probability that the translated message is wrong? Assuming that the message is wrong, when there is at least 1 bit error. So we have to find when the at least 1 bit error is there. Okay. So here you can see that X is a bit changed or bit error is I think considered as same. So we have to find out the probability. That probability X is greater than or equal to 1. Right? We have to find out this probability here. And we have we already know the value of P and N here. So now you can put the values and find out this probability.
Yes, ma'am. Got it. Got it.
Okay.
I can calculate.
Yeah, fine.
So the next one, how it will be?
So next question is, an error can be recovered if the number of faulty bits is less than or equal to. If we send a string, find the probability that the string is either correct or can be recovered. So we are given that error can be recovered if the faulty bits is less than or equal to 1. Okay. So you have to find out the probability that X is less than or equal to 1. Fine.
Okay,
Because
0 and 1.
0 and 1. If it is correct, then the value of X will be 0. And for recovered, it is given that the less than or equal to 1. So basically, you have to calculate the probability X is less than or equal to 1.
So if I find this and above question also 1 minus this, so I'll get the answer, I hope so.
In the above question, it is at least 1. So the probability will be X greater than or equal to 1. But in this question, it is X less than or equal to 1. Okay?
That's what he is saying. 1 minus probability of X.
Yeah.
Yes, that's what I
Okay, next. Any question from this? 11.4?
No, ma'am.
Okay. Then 11.5. Yeah, any question from this?
not yet solved it, but you can just give me idea of orally. No need to solve anything, if possible. By TA actually solved the practice assignment. The activity is not yet started.
So you're asking the things that you are needed to solve this activity, right?
Yeah, just actually one by one, just orally go through, ma'am. Just we can able to understand. I'm not yet solved. So if you just go orally say that, it would be easy for me to do the calculation and everything.
Okay.
Also, as it is recording, people would be easily able to understand. So recording is happening. So they'll also find easy.
Okay, fine. So the first question is, let X be the binomial random variable with mean 5.4 and the N is 9. Now we have to calculate the variance. So someone has asked this question also, so I am solving this. So mean is 5.4 and n is 9. Okay, we have to calculate the variance. So x is a binomial random variable. N is given 9 and mean is given 5.4. What is the formula of mean for binomial distribution?
N into P.
N into P.
So value of NP is given as 5.4. Now we are given the value of n here as 9. So 9p will be 5.4. Okay. So p will be equal to 0.6. Okay. Now we have to calculate the variance of x. So what is the formula of variance of x?
N into P into 1 minus P.
Now you know the value of n also, and you know the value of p also. So you can calculate it, right?
You got it, ma'am.
Okay. Next question is, x is a binomial random variable such that expectation is x, variance is 3.6. Again, you have to find out the value of n and p. You know the formula of x, which is formula of expectation of x, which is np. You know the formula of variance of x, which is np 1 minus p. So you just have to put the values and solve the equation. Then you will get the value of n and p in the same
Yeah,
way.
got it. Yes, easy.
Now you have to find out the probability at x equals to 3. So in this question, you will be calculating the value of n and p. Okay. And you know the value of x, which is 3. So just use the formula of PMF and then you will
Yeah.
calculate it. Okay. Question 4 is, suppose a fair die is thrown 90 times. The expected number of times 4 occurs is 15. What is the significance of the expectation? Option 1 is, if we throw the die for 90 times, for exactly 15 out of the outcomes will get 4. And the second is, if we throw a die for 90 times, we can expect 15 of the outcomes to be 4. So tell me what should be the correct answer.
Second option.
Yeah, second, because we are taking the expectation. Expectation tells us about the expected number, not the exact
Can
number.
you just write it down? Actually, I didn't get it.
See, it is very simple. Expectation, what expectation gives us? Expectation gives us the expected number, not the exact number. Okay. If you are
Okay.
throwing a die 90 times, if the expectation of the expectation is given is 15, then it is giving you the expected number of times you will getting a 4, not the exact number.
Okay. Okay.
Okay. Yeah. So next question, you have to calculate
Okay. Okay.
expectation of y. So you can simply use the formula expectation of x or expectation of y, which is summation x into px or summation y into py. So you are given the value of y and you are given the value of probabilities also. You can use the formula. Fine. Do I need
Yes,
to
ma'am.
solve this or you all got it?
No, ma'am, no need.
Okay.
No need to.
And for variance also, you know the formula. You need to calculate the expectation of x square also, and you have already calculated here the expectation of y. You can use the formula and you will get the value.
We can directly write y square into P of y sigma.
What? Y
Sigma
square.
of sigma of summation of y square into P of y.
That will give you the expectation of x square, not variance of
Right,
x.
ma'am. I'm sorry,
Okay.
ma'am. Yeah, sorry, sir.
Okay. Okay. no
My
problem.
expectation of y, what is the formula? Can you remind us?
Okay. Expectation of y is summation of y into probability of y is equal to y. Okay. And here you have to take the range over y.
Okay, ma'am.
Fine. You know the formula of variance? It is simply expectation of y square minus expectation of y to the whole square.
Okay,
Okay.
ma'am. Got it.
So next question is, suppose an urn contains marble of 2 different colors, red and yellow. Okay, I am making a figure also. So, and suppose this is the earth. This is red and yellow. So two different colors, red and yellow. A marble is drawn randomly from the urn and its colors has been recorded. Then the marble is kept in the urn and remixed before the next draw. Suppose the proportion of yellow and red marble in the urn is pi 1 and pi 2. Let the urn has 15 marbles, out of which 6 are red. So 6 total 15 we are given, out of which 6 are red. So remaining 9 will be yellow. Fine.
Fine, ma'am.
Then it is saying that a total of 10 marble is drawn from the urn and in the stated manner. Based on the given information, answer the question. So we have to calculate the value of pi 1 and pi 2. So pi 1 is representing the proportion of yellow and pi 2 representing the proportion of red. Pi 1 for yellow. So what will be the proportion of yellow?
9 by 15.
Yeah, simply 9 by 15.
Yes,
Pi 2 will be 6 by 15.
6 by 15.
Yeah.
What is the significance of this question?
For this question, you don't need this. For next question, you will be using this, I think. 10 marbles are drawn. The next question is, in the experiment, first find the standard deviation of number of yellow balls drawn. So
Under root of variance square.
yeah, you
Variance.
have to find out the variance. Then you will take the under root.
How to find
So-
variance ma'am, in this
Yeah.
question?
Yeah, I'm telling you, just a minute. So it is given that you are taking 10 balls, okay? And the probability of finding a yellow ball will be, we have calculated it as, it was 9 by 15, right? Is it right or no?
Yeah, right. 9 by 15.
Okay. And you have to find out the variance, the formula of variance is NP1 minus P. So you need to find out the value of P and N. So P is 9 by 5. N will be R10 because we are taking the sample of 10 balls. Okay,
Yeah ma'am.
fine.
N will be not the total number.
No, we are taking a sample of 10 marbles. Okay, so and we are having 9 yellow balls. And X is representing the number of balls drawn. So maximum you can take, you are taking maximum 10 marbles.
Okay, N is 10 here.
N is 10 then, okay. And yellow
Understood.
balls are 9. So out of N, how many balls you can get as yellow? Something like this. Okay, this question. So N will be 10.
You got it.
Yeah, 11.6. Any question? Or all the question?
No ma'am.
Just go orally, you can go through.
Oh, okay, okay.
Ma'am,
Yeah, yes.
I mean the last question, can you just show the last question? No, you are just solved it now, just the solution part.
yeah.
Ma'am.
Hmm.
Okay, we just have to apply this n into p into 1 minus p. to the-
This is the formula of variance, and you have to find out the standard deviation. So take the square root of it, and you will be getting the standard deviation.
Okay,
The
ma'am, got it.
value of P and N, they have calculated. So just put this value. Okay. So question 1 is, which of the following statement is true about the hypergeometric distribution? So total number of items can be uncountable. So in hypergeometric distribution, total number of items is countable, not uncountable, right? Right or no?
Yes, yes.
Right, ma'am.
It's
Countable.
countable.
Yeah, it's countable. So statement 1 is incorrect. Next is population can be divided into more than 2 groups.
No.
In hypergeometric distribution, we divide the population into 2 and only 2
Two.
groups. Right?
Yes.
So this is also incorrect. and probability of success is same for each trial. This is also incorrect because in hypergeometric distribution, probability changes from trial to
Yes.
trial. Okay, so none of the above will be correct. Now next is, suppose that 5 fruits are randomly chosen from a basket containing 20 fruits, of which 16 are good and 4 are rotten. Y denotes the number of rotten fruits. So question 2 is, find the possible values of Y. So total 4 fruits are rotten. Okay, and you are taking
Yeah.
5 fruits. So maybe no fruit is rotten, or maybe 1 fruit, or maybe 2 fruit is rotten, or maybe 3, or up to 4. So 0, 1, 2, 3, 4, right? So this is
Yes.
the answer. Next is probability Y is equal to 2. So you just have to put the formula. X is given, Y is given. And we are taking the 5 fruits and will be 5. Okay. And we have to find out the value of P. P will be
15. 15.
P will be 50.
16, I think.
P is probability. It cannot be greater than 1, you know.
Okay, ma'am.
Yeah. So Y is denoting the number of rotten fruits. So probability of rotten fruits will be 4
4
divided
by
by
20.
20.
Yeah, ma'am.
Okay. You just have to put the values, then you can find it.
Ma'am, can you just show the PMF for this hypergeometric? You have already written, ma'am. I couldn't note it down.
Oh, okay.
I think during earlier part in the lecture you have done, ma'am.
Yeah, this is.
Yeah, ma'am, this one.
Yeah,
Just
this
a
is
minute,
M.
just a
Okay,
minute.
MCX. Oh, okay.
The capital N here is 20 and the M is 4. The N minus M is 16
Oh, have you written it?
and X is equal to 2.
Yeah, ma'am, done, ma'am.
Okay, okay. Just a minute.
Ma'am, that capital N will be total number.
Yeah, in hypergeometric, capital N is the total number of items you are having.
And
you
what
then
about
you
small m, n?
Yeah, listen. Capital N is the total number of items. Suppose you are having 20 balls in a box. Okay. Then capital N is 20. And then out of 20, suppose 9 are of red color and the remaining are of another color. Okay. So
Got it, ma'am.
we just divide our whole population into 2 categories. One category will be having M items and another category will be having capital N minus small m items. Right?
Ma'am, what is small n in that case?
Yeah, small n is the sample we are taking from it.
How many choose a board like this?
Yeah.
Okay.
So the thing is like over there, the question asked P is equal to 2. So 4C2 into 16.
You are talking about which question? Yeah, this one.
Yeah, ma'am, can you just please write using that
Yeah, this one,
PMF?
this question.
Okay.
So here they are asking probability of 2 rotten, right?
Yeah, 2 rotten.
So 4 are rotten maximum. So 4C2 divided by 20C2, correct?
No. See, here it is given that suppose that 5 fruits are randomly chosen. We are taking a sample of 5 fruits from the
But
basket.
maximum N value can take 4.
No, let me explain first. It is given that 5
Okay.
fruits are randomly chosen from a basket containing 20 fruits, out of which 16 are good and 4 are rotten.
Okay.
Here, it is not given that we are taking the fruits without replacement. So it is the example of binomial distribution. Okay. This is not hypergeometric.
It's nothing to do with the distribution. He is asking only for the possible values of Y, which can be 0 to 4.
Yeah, possible values of Y can take 0 to 4. Yes.
So can you solve this? P equal to y,
Oh,
P of
okay,
y equal to 2.
okay, just a minute. So we are asked probability of y is equal to 2. Okay, we know the formula, which is NCX p to the power x 1 minus p to the power n minus x. So we are taking the sample of 5. Okay, so n will be our 5, and x or y it is given as 2. And the probability of taking the rotten fruit, it will be 4 by 25. Fine. So here p is given as 4 by 20, which is 1 by 5. So 1 by 5 to the power 2, 1 minus 1 by 5 to the power 5 minus 2, which is 3. Okay, you have to solve this question in
Okay.
this way.
I thought, sorry, I thought it's hypergeometric, but
No,
it is
yeah.
No,
It is
just-
good.
binomial.
Just a
Yes,
minute.
got it.
How do we
Yeah.
infer that it is with the replacement? If it is with the
See.
replacement, y can assume any number.
See, it is given that 5 fruits are randomly chosen from a basket.
Correct.
Okay.
They're not replaced.
Hi, not replacing. If it is replacing, it will be mentioned that we are taking the 5 fruits without
In that
replacement or
case,
something.
y will
Hmm.
assume any number. There is no limitation. Every time you probably pick up the rotten.
No.
Of course, you're replacing it.
No, sorry, I didn't understand your question. Will you please repeat?
No, the question is, how did we conclude that this is with the replacement? Because I infer, when I read this, the value of a y, if it is restricted up to 4, that is because we are not replacing it.
Yes, we are without replacement.
It should be without replacement.
Yes, it is without replacement.
So it cannot be binomial. The logic for second and third should be the same, right? Our assumption should at least be continuous. For answering second, we are assuming it is
Here you are taking the 5 fruits simultaneously. Okay, not one by one.
correct.
Okay. So if you're taking simultaneously, then it is saying that the value of y is 2, which means that out of the 5 fruits that you are selecting, the rotten fruits will be 2. Okay. So it cannot be hypergeometric.
So question can be clear, ma'am.
Let's solve this and see whether what is the expected answer, whether we are in line with their logic.
Okay, so we will solve this question in this manner. Fine. Now just find out these values. 5 CPUs.
Ma'am, it has to be 10. 5, so 2 is 10.
It will be 10. Now tell me the value. 1 by 5 square.
Point
0.04.
into 0.75.
Ma'am, I have a doubt in this question, ma'am, that how you have taken 1 by 5, ma'am, because 2 fruits are rotten. So it will be 2 by 5. Can you please explain this, ma'am?
See, y is representing the number of rotten fruits. Okay.
Yes, ma'am.
So what p will be representing? The
Probability.
probability of rotten fruits, right?
Yes, ma'am.
Out of all. So rotten fruits are 4 and total fruits are 20. So probability of selecting a rotten fruits out of 20
Oh, yes, ma'am.
fruits.
Got it.
So
Got
it
it,
will
ma'am.
be 4 by 20, right?
Yes, ma'am.
Ma'am, it has to be 0.512, ma'am, not 0.75. My mistake, ma'am. Instead of 0.75, we have to use 0.5512. I've done the mistake. 10
Well,
into 0.04 into
okay,
0.512.
tell me the final answer.
Point 2048.
Yeah, it will be the answer. So now what is the doubt? Yeah, you can ask if you have any doubt still. Is it fine? Should I move on to the next question or explain it more? Are you getting what this statement is saying? It is asking the probability that y is equal to 2, means we have to find that out of 5 fruits that we are taking, only exactly 2 fruits will be rotten. You are taking the 5 fruits randomly in one go. It is not like you are taking one fruit and then you are taking another fruit. You are taking 5 fruits simultaneously at one time only. Okay, so it cannot be hypergeometric. Is it fine? Hello?
Ma'am,
Yes,
is there
ma'am.
any telltale sign that the
Okay.
question belongs to hypergeometric or binomial, ma'am?
Yeah. See, in hypergeometric, just a minute. In hypergeometric, you take you without replacement is used. Okay, suppose you are taking 5 sample of
Sorry, ma'am, can't hear you. Is it my network?
Yeah, no, it is. So we can't hear you.
I think we should write in the chat box.
hello.
Yeah, now like we can hear you.
Fine.
Yes,
Fine.
ma'am.
But we didn't hear you. What did you say for past one?
Okay, okay. See, in hypergeometric, suppose if you have to take the sample of 5 fruits, then you will first select one fruit and you will not put it back. Okay. Then you will select the next fruit and you will not put it back. It is the without replacement. If the fruit is once selected, it will not put back into the box. But binomial, it is not like that. In hypergeometric, probability also get changed. Uh, suppose you have a box in which you have 4 white balls and 3 red balls. Fine. So if you are taking, first you are taking a sample of 3. Am I audible or no?
Yeah.
Audible, ma'am.
Okay. So it could be like 2 white and sorry, just a minute.
Ma'am, your voice is not.
Hello.
Yeah, now we can hear you.
Yes. No.
Yeah, am I audible, right?
Yes, ma'am.
Yes.
Yes,
Did
ma'am.
you get my point, what I was saying here? That in hypergeometric probability of success also changes. Suppose you are taking one red ball from here, then it will be four white and two red balls. Okay, now again you have to take, now if you are again taking one red ball, then it will be four white and one red ball. Here the probability of selecting one red ball is 3/7, right? And here it is 4/7. Now, suppose if you are taking
4/7 is for white
2
ball.
by 6, ma'am.
sorry.
That
2 by 6.
Yeah, it will be 2/6, right?
yes, ma'am.
And if you are taking three white, just a minute, how should I explain it to you?
I think this particular problem needs a little careful analysis.
Sorry, your voice is getting.
You are not audible.
Sorry, I'm not audible, or she's
No,
Yeah,
you
No,
are
you,
your
she's
audible.
voice.
not.
Ma'am is not.
He's not audible.
She I think she has some technical problem.
Am I audible now?
Now, yes.
Yes, ma'am.
Let me explain it again.
Yes, ma'am, please.
Yeah, am I audible?
Much better.
Yes.
Okay. So suppose you are taking you have four white balls and three black balls. You are taking one black ball. What will be the probability of selecting black ball? It will be 3/7, right?
Just a
Yes.
minute.
Okay.
We are
Now
taking
you,
one by one, right?
yeah, okay. Now you have taken one ball. So it
Okay.
will be four white and two black remaining. Out of these, you have to select another one black ball. Fine. Now, what will be the probability of selecting black ball out of these?
2/6.
It will be 2/6. So you can see that the probability of selecting black ball is changing here, right?
Yes.
We understand this. This one at a time, we can very clearly see the probability changes. So we will simply multiply both, and then we conclude that probability of collecting two black ball or a white ball is this.
So you
In
are
this
asking that
example,
okay, you are
we
in
say
this.
5 fruits are taken.
Mhm.
Now, after having taken 5 fruits, what is the probability that 2 of them will be rotten?
Yeah.
Now, this is where I want little more clarity in how to interpret whether it falls into one of the classified binomial distribution or
So if it is hypergeometric,
hypergeometric.
it will be mentioned that you are taking the fruits without replacing it. Okay. It will be mentioned that you are taking the fruits without replacing.
If that is so, how did we conclude that for problem number 2,
Okay. You
the
are
value of
asking
y
that
will
if,
not go beyond 4. All the 5 could be rotten. If I agree with your assumption,
yeah, okay.
I take the one red bulb, put it back, and I can take all the 5. My confusion comes only because of that.
Just a minute.
For solving 2, if I assume it is without a replacement, then how did I change my logic for 3.
Then value of y will be changing for different takes, right?
True. Oh, there are
Will
two
not be
scenarios. No,
fixed.
wait. There are two scenarios. One, we are assuming that it is without a replacement, or right? Or with the replacement.
With
Okay.
If we
replacement.
assume it is with the replacement, answer for question number 2 is 0 to 5. In which case, here I can take this is without a replacement. Sorry, with the replacement. So the probability will be different.
I think the question is
So-
saying that out of total, you are actually
See.
getting that 5 sample.
Okay.
And within that sample, we are checking whether 2 are rotten or not. I think that's what the question is trying
See,
to ask.
you are saying that if it is with replacement, then y can take only value up to 0, 1 to 4 or 0, 1 to 5, right?
Correct.
It will be 0, 1 to 4 only because you are taking 5 fruits. The number of rotten fruits are still 4, okay? So number of rotten fruits can maximum be 4 only, not 5
That is without a replacement.
with replacement.
Why? If you are replacing, you are taking a rotten food and replacing it inside. So it will be the constant all the time.
So maximum number of rotten fruits are 4 here, right? And we're taking a sample of 5 fruits. When the number of rotten fruits are 4, how it can be 5?
Okay.
Fine. X will take value 0, 1, 2, or 4. If you're taking 5 fruits, then possibilities are, if there is possibilities are no fruit is rotten, or 1 fruit is rotten, or 3 fruit is rotten, or
Okay.
4 fruits are rotten. Maximum 4 it can take. It cannot be 5. Fine.
Okay.
Now is
Ma'am,
it
I
clear?
think the way to see it is that we have already taken out 5 fruits out of 20. And within that 5 fruits, we are trying to see whether 0 rotten, 1
Yes,
rotten.
yes.
Yeah. So within that 5 fruits that we have selected, we have to find out the probability that the exactly 2 fruits will be rotten.
Yes, ma'am. Got your point, ma'am.
Okay. So rotten fruits in the sample of 5 fruits cannot be 5. It can
Maximum
be
4.
maximum of 4.
So if I add
Fine.
up P y equal to 0, 1, 2, 3, 4, it should add up to 1.
Why are you adding the probabilities?
No. I mean, it should be one of the 4, right? 4 possibilities.
Yeah, 4 possibilities will be there. So
Yes,
the
if I add
random
up all,
variable will be taking values 0, 1, 2, 3, and 4 only,
let me check
not
it
5.
out. Okay, I want to check it out.
Oh, okay.
I will go.
So,
Thank you.
okay, you are saying that if you add the probability should be 1.
Yes.
1. Yes, yes.
Probability of PMF.
That's one way of cross verifying.
Yeah, you can check it. Yeah, random variable y will be taking only 0, 1, 2, 4, not 5. Yeah, you can check by the property of PMF. Fine. Okay, till then we solve the next question.
Yes.
Okay. So what is the next out? Any questions on this?
Yes, ma'am. Just you can give the idea to clear.
Question 4 and 5.
Yeah.
Okay, 4 is the probability of statement 1 is the probability of success is same for each trial in the hypergeometric distribution. Now tell me,
False.
is it correct or no?
False, ma'am. We have already
Yeah,
seen.
is
No.
it false? It's false. Statement 2 is the samples are drawn without replacement in hypergeometric. It's true.
Yes.
We
True.
have discussed it. So statement 2 only will be correct.
Yes, ma'am.
Fine. Now,
Right.
question number 5 is, suppose we draw 8 cards from a pack of 52 cards without replacement. Then what is the probability of getting less than 3 spade cards? Okay. So you just have to find the probability that x will be less than 3. So you have to find out the probability for x less than 3. It will be probability x equals to 2, x equals to 0 plus x equals to 1 plus x equals to 2, right?
Yes.
How you can solve it? Let me show you. The question is that we are taking the 8 cards out of 52, okay? And the probability that probability of getting less than 3 spade cards. So number of spade cards are there. How many spade cards are there?
13.
13.
13, right? So in this case, we are selecting no spade cards. So out of 13, we are taking 0 spade card.
0.
So remaining will be 39. We are taking the 8 cards from the
8.
remaining 39 only, okay? And
Yeah.
total 52
15
means
to C 8.
8. Okay, out of 52, we are taking 8. So this will be same in each the case. Okay, out of 52, we are taking 8. Now we are taking 1 spade card. So out of 13, we are taking 1 spade card. And out of 39, we are taking remaining 7.
7.
So in this way, you have to solve this question. Fine.
Yes, got it.
Okay, now
Ma'am, when to
activity.
apply that formula we have given for hypergeometric ones?
What?
Ma'am, you have given that PMF formula for hypergeometric one.
Mm-hmm.
And when to apply that formula? Because this question looks, I mean, like it is based on that hypergeometric one.
It's without replacement.
Is it?
Yeah, it's mentioned, right?
Yeah, so you
Oh, sorry,
can
sorry, sorry.
use that
Ma'am,
formula
I thought
also.
it.
Yeah,
If
it's
you can, then
explicitly mentioned it
otherwise
without
you can
replacement.
solve it by this method also. This is the correct. For hypergeometric, I will have to see. This is the correct. So you can solve it or
No,
This is
no,
hypergeometric only, right?
okay.
but
Spade cards. Listen. So yeah, you can solve this, I think, in that manner also. You solve it and check the answer.
okay, ma'am.
Okay. You can, I think, make 2 categories like spade cards or non-spade cards. Total 52 cards.
Okay, ma'am. I'll check.
Yeah, I think in this way you can solve this question also. Yeah, any doubts on this or all the question?
Ma'am, that hypergeometric distribution
So first
formula
question
is
is a
used.
box con
Hello, ma'am. Hello,
yes.
ma'am. My
Yes.
question is, when we will use that formula hypergeometric distribution, that is we will apply that formula when it is when the question is asked without a replacement. In that
Yeah,
case,
if it is
Yes,
mentioned
yes.
in the question that you are taking the samples or taking the items without replacing it, then you can use. Or
okay.
there should be 2 categories also. There are some conditions like from which you can identify whether you have to use the hypergeometric or no.
Ma'am, that only that makes me confusion, ma'am. It makes
So you can uh, so questions will be like you will be having a number of items and that can be categorized into categories. It should be like that. Some of the items will be of one category and remaining will be of the another category, and you will be taking the sample without replacing. the items. It will
Ma'am,
be
N
something
will
like
be
this.
sample without replacing.
Yeah, N is the sample without replacement.
Okay.
If you are
And
taking,
that N minus M will be the remaining part.
yeah, suppose we have taken balls, red balls and blue balls. If you have 20 balls, suppose 10 are red, remaining 10 are blue.
Yes, ma'am. Getting.
Okay, so M is one category, capital N minus small m is another category. And
Okay,
out
ma'am.
of these capital N, you are taking N. So suppose out of these M, you are taking small x number of items, and out of these, then you will be taking small n minus x number of items. Fine. If you
Right.
add x plus small n minus x, it will be n. Okay.
Yes, ma'am. Got it. Thank you, ma'am.
Okay, fine. This activity 11.7. So all the questions need to be solved or any particular question? Have you solved this activity or no?
No, not solved.
Not solved.
No.
Okay. So first question is, a box contains 7 items, out of which 2 are defective. A sample of 4 items is to be selected randomly without replacement from the box. If the random variable x represents the number of defective items in a selection of 4 items, then find the expectation of x. So here you can see that it is the example of hypergeometric, right?
Yes, right.
Okay, let me. Do I need to show you or you all got it?
Yeah, it
So
is
total,
hypergeometric.
yeah. So total number of items are 7. Capital N is 7.
7. Yes.
So one
Two odd.
category is defective. So suppose small m is 2, and the remaining 5 will be non-defective items. Okay. Now you are taking the sample of 4 items. So 4 item means small n, which is the sample size, which it will be 4. Now you have to find out the expectation of x. So you know the formula of expectation of x in case of hypergeometric?
N by n.
I have told you this previously. So you know all these values, so you can put the values in the formula and you will get the answer of expectation of x, right? Question number 2 is, let x follows hypergeometric distribution in which n objects are selected from capital N objects with m plus 1 of the objects being one type and capital N minus m minus 1 of the object being second type. So what is the expected value of x? So you see, in this question, it can be m plus 1, then it will be remaining n minus m minus 1. Okay. So the formula of expectation will be n into m plus 1 divided by capital N. Clear? Hello.
Can you just
Am I audible or no? I think there is a network issue.
Ma'am, can
Your
you please
screen.
repeat what you have just said?
Okay. So in this question, it is given that m plus 1 of the objects being one type and remaining of the second another type. So in this, we are taking the m of one type. We can take m plus 1 also. Then the remaining will be capital N minus m minus 1, right?
Yes.
So the formula will be n into m plus 1 divided by capital N. Simple?
Yes, ma'am. Yeah, ma'am.
Yeah. So this option will be correct, third option.
the first question, can you repeat? So
Okay.
the n is here 4 items.
Capital N is 7,
Okay.
small n is 4, and
Okay.
small m is 2.
Okay.
Fine.
So, but remaining one is there. So actually, in the lecture also, I didn't understand n and small m and capital N. I understand is a universe, and n is whatever the question is. What is the mean m?
Okay. Let me explain it again. So this is the total capital N, right?
Yes. Yes.
There are 2 categories. Suppose it is M. You can take any variable. Standard
Okay.
notations is M and small m or capital M. You can take any variable. So
Okay.
here we are taking it as small m. So capital N minus small m will be the number of items for remaining category, second category.
Yes. Yes.
Now you are taking a sample of it. Okay.
Okay.
Of size small n. So
Okay.
it will be consist of items from this category also or this category also.
Yeah.
Fine.
Yes.
So suppose out of these small m, you are taking small x items. And out of these, you are taking small n minus small x.
Okay.
Fine. Now you understand.
Yeah.
The total sample size is small n.
Okay.
And the
Ma'am.
number of items of one category is small m. And other category is capital N minus small n. Fine.
So it is kind of Bayes theorem.
Yeah, you can relate it with that also.
Yes, it is purely depends upon the probability of defective.
Hmm.
So it's similar to the Bayes only. Okay.
Fine.
So, but here actually the 7 total, so 2 are defective. And sample 4 items select randomly. So the small n is 4 and m is 2.
Totes.
Can you draw it?
Yeah,
Can
total
you
7
just-
items.
Okay.
Yeah, 2 are defective. So remaining 5 will be non-defective. And out of these,
Okay.
you are taking sample of 4.
Okay.
Fine.
Okay, ma'am. So what is the formula here? N into m.
Yeah, formula of expectation is small n into small m divided by capital N. So small n is 4, m is 2, capital N 7.
Okay, they are asking about the defective items. Okay, thank you.
So the third question is, X is following hypergeometric distribution and the sample size n is very small compared to the population size capital N. Now we have to choose the correct options. So first one is hypergeometric is about summation of xi's, where xi is a ith Bernoulli variable with success probability m divided by capital N. So is it right or wrong?
Looks right.
Yeah, it is right. Yeah, let me show you also. What is the formula of variance of x in the case of hypergeometric? It is small n, m. And in the question, it is given that capital N, it is given that small n is very small compared to population size capital N, right? So then you can say that if small n is very, very small compared to capital N, then capital N minus small n divided by capital N minus 1. It will be approximately equal to 1, right?
Yes.
Fine. So now the formula will be n into m divided by capital N, 1 minus small m divided by capital N. And what is the formula of variance of x in case of binomial distributions? It is n p
Into P into
1 minus p.
1 minus p.
Yes,
So you can compare these both. Okay, similar.
Yes, ma'am. Yes, ma'am.
And p is m divided by capital N, right?
Yes.
So this is the statement. So in this condition, hypergeometric is the summation of xi's, where xi's are ith Bernoulli variables with the probability m upon capital N. Or expectation is N by N. We have already discussed it. Variance, we have already seen it. Okay, this is the formula of variance in that case. Capital N minus small m divided by capital N. Right?
Yeah.
So all these options will be correct.
Okay, ma'am.
Now the question number 4. Sumit, a fruit seller, has a carrot which contain 250 green and 250 red apples. A customer comes to Sumit's shop to buy apples and select 5 apples randomly without replacing them. If the random variable x represents the number of green apple in the selection of 5 apples, then find out the value of variance of x. So this is also the case of hypergeometric distribution, right? Total we will be having 250 plus 250. So capital N will be 500.
Yes.
Fine. And there are 2 categories, green and red. So we have to find out the x is representing the number of green apples. So small m will be number of
250.
green apples. M will be 250. Small m. Fine.
Yes.
And we are taking a sample of 5. Okay. So small n will be 5. Now you know the formula and all the values. You can find it out. Fine.
Okay.
Ma'am, M you said was 250.
Yes.
Okay, ma'am.
Here both the values, both the categories are having same number of items.
Oh, yes, ma'am.
Hmm.
Ma'am, I have a question, ma'am.
Yes.
Ma'am, question is that is there any relation between the experimental distribution and binomial distribution? Any
By
formula?
binomial distribution and experimental distribution.
Yes, ma'am, because in extra activity weekly, ma'am, in weekly extra activity,
Okay.
I was seeing that I was making that project, ma'am. So
Experimental distribution. What is experimental distribution?
I think he's referring to exponential.
Exponential. Exponential is different. You are talking about exponential distribution or
ma'am, experimental, ma'am.
experimental distribution?
Ma'am, just having a doubt, that's why I want to clear it. In weekly extra activity 4, it was there.
Hello.
Yes, ma'am.
Ma'am, can't hear you, ma'am.
Hello.
Yes, ma'am.
Now better.
Yeah. Okay. Okay. Yeah. Repeat the question, please.
Ma'am, question is, ma'am, is there a relation between the binomial distribution and the experimental distribution, ma'am? Any formula? Any
Okay.
relation?
I'm not sure about the experimental distribution. I will have
Ma'am,
to
because
see
I
it.
was making that weekly extra activity 4, so I
Hmm.
want to be confirmed that when I was calculating experimental distribution, it was probability was equal to the student by total number of students. This will be the experimental probability. Just I want to clear my doubt.
I'm not sure about the experimental distribution. I will have to say it, then I can tell you.
Okay, ma'am, no problem.
Okay. Okay, fine. Yeah, so you got the question number 4?
Yeah, ma'am. So it is 5 into 250 divided by 500. That NM formula, right? Variance formula.
Yeah, variance formula. I have written
Okay.
it also in this formula.
Yeah, ma'am. So that the n minus n divided by n minus 1 is equal to 1. So no need to worry about it, right?
No, you don't need to change it. The formula will be this only, I guess. Yeah.
So even that, so okay, very, very small, it is not a very, very small, so that it is applicable here.
No, when small
N1,
n is very, very small as compared to capital N. Here m is 250, which is half, not very small. Sorry.
okay.
N is 5 and capital N is 500.
It is, yes, it is 1%, right?
You can find out the value from both the formulas and see what is the difference. How much difference is there?
Okay, without that particular and with the particular
Hmm.
n minus n. Okay.
I think it will be approximately same.
So that n minus
Yeah.
n minus 4, I mean, 500 minus 5, 490. Yes, it's approximately same. It's equal to 1. Yes.
Yeah. Because that formula also came from the main formula only, right?
Yes, ma'am.
This came from this only. So you
Yes,
can use
yes.
any of them.
Got it.
Yeah. Now the first question is Poisson distribution approximates the binomial distribution. When number of trial is small and the probability of success is very small. Number of trial is small, probability of success is very large. Number of trial is large and probability of success is small. Poisson distribution cannot be approximated as binomial distribution. Now think and tell me.
3, ma'am. Option 3.
Yeah, option 3 will be correct. Fine.
Oh, actually, can you just explain them again?
You can see it by the proof. There is a proof in which you take capital small number of trials small n tending to be infinity.
Okay.
You can see the lecture of the Usha ma'am. She has explained it, because
Okay.
if I solve it, it will be very lengthy.
Understood.
Okay, now the next question is, let X denote the number of radioactive particles passing through a counter in 1 millisecond time interval. The probability that number of particles passing will not be counted is 0.01. Assuming that X follows a Poisson distribution with the parameter lambda equals to 3, find the probability that the number of particles counted during a specific time interval is 3. So solve it, then I will explain. Try to solve it at least.
Okay.
Done.
I'm getting confused, ma'am.
Okay. So the question is, X is denoting the number of radioactive particles. Fine. And we are asked to find out the probability that the number of particles counted during a specific time interval. So let us suppose a random variable y. Okay, we are taking a new random variable y, which denotes the number of particles which are being counted during a specific time interval. And we know that the formula of PMF of the Poisson distribution is okay. So here we need to find out the value of lambda and value of y we are already given. We are asked that the number of particles counted during a specific time interval is 3. So we have to find out this probability for small y is equal to 3. Now we have to find out this lambda. Fine. Am I audible or not?
Yes, ma'am.
Audible,
Yeah,
ma'am.
audible, right? Okay. So you all got it? That what is this and what is how we have written this?
How did you get y equal to 3, ma'am?
Yeah, it is given that find the probability that the number of particles counted during specific time interval is 3. Okay.
Okay.
Okay. Read the question again. It is given that X is denoting the number of radioactive particles passing. Okay, X denoting all the particles which are passing, and we have to find out the probability for the number of particles which are being counted. Okay, so we are taking a random variable y, which represents the number of particles which are being counted during the specific time interval. Okay. And number of particles being counted during a specific time interval is 3. I mean, for this, we have to find out the probability. Okay, when it is 3. Okay, so in this formula, the value of small y will be 3. Now we have to find out lambda. Fine. So we are given that X is assuming X follows Poisson distribution with parameter lambda equals to 3. So what lambda is representing here? Can anyone tell me? X here lambda. What?
Older mean, older
Yeah,
average.
it is representing the average number of particles which are passing through a counter. Okay. And for y, the lambda will be representing the average number of particles which will be being counted. Not all the particles, but the particles which are being counted. Fine.
Oh, ma'am, can you please repeat, ma'am? Just missed it. When you say lambda equal to 3, ma'am, it means?
Here it is given lambda equals to 3, right?
Yes, ma'am.
So what is representing this lambda? You know, for Poisson distribution, lambda is the mean.
Average.
Yes.
Okay. Okay. So what is the mean? So lambda will be representing that the mean number of particles, or we can say the average number of particles which are passing through a counter. That will be 3. Fine.
In 1 millisecond.
Yeah, in 1 millisecond.
Okay.
in this time interval only. Okay. So we are given
Yeah.
this, but what we have to find is we have to find the average lambda. We have to find the value of lambda, right? What is lambda in this case? Lambda in this case will be the average number of particles which are being counted during the specific time interval, right? You can represent it as lambda dash also.
Yeah, ma'am.
Don't get confused.
It's a different
Okay,
lambda.
okay.
I can understand, but
Yeah,
the
yeah,
thing is,
okay, yeah. Yeah, you
the
can represent it lambda dash, not lambda. Fine. Sorry, by mistake. For x, it is lambda. Okay.
Mhm.
And for y, it is lambda dash. I am representing it with lambda dash. So now we
Yeah.
have to find out the value of lambda dash.
Ma'am, how can we
So you
use
know that
lambda dash? I'm saying, ma'am, how can we use
it is just
lambda
for
to?
representation.
No, no, ma'am. I'm just asking, ma'am. We have to use that value
What?
of lambda to calculate this lambda dash.
Yeah, we
Ma'am,
will
there
use
is
that
some
value of
specific.
lambda.
Okay, ma'am. Okay.
Okay. This is just for representation. Here it is written as lambda, so I am taking it as lambda dash. Okay. So we have to find out the average number of particles which are being counted. So how can we calculate it? You know, it is given that we are given the probability that the number of particles with passing will counted is 0.01. The probability of number of particles which are not being counted, it's 0.01. So what will be the probability that the number of particles that are being counted? It will be 1 minus 0.01. Fine. Which is equal to 0.99. Fine or
Okay.
not?
Yes, ma'am.
Did you understand this
Ma'am, got
statement?
it. Yeah, ma'am. Yeah. When we are not
Okay.
counting, it is 0.01.
So from this statement, not counting probability is 0.01. So for the counting, the probability will be 1 minus 0.01. Okay. So this probability will be this 0.99. Okay. Now the lambda is 3, which means lambda dash will be 3 into 0.99. Fine. Then it will give you the average number of particles which are being counted in the time interval. Okay, total three, average number of particles passing are 3, and 99% of the particles which are passing are being counted. Fine. So you can find out
Yes.
the value of lambda dash in this way. Okay, 99% of 3 number of particles
Yes.
will be counted. Fine.
Yeah,
Got
got
it?
it.
So this will be 2.97. Okay. Now it is almost solved. So we have to find out probability for y equals to 3. So e to the power minus lambda, lambda is 2.97. Then lambda to the power y, so 2.97 to the power y, which is 3 divided by 3 factorial. Fine. You all got it?
Yeah, got it.
Oh, ma'am, when you wrote 1 minus 0.01, ma'am, what was that probability?
It will be the probability of being counted. Since it was given the probability of now not being counted. Fine.
And when you say probability of x is equal to 3, then what is exactly we are saying?
Probability x equals to 3.
Yeah, ma'am. The last thing which we have
Then
calculated.
it will no, we have calculated probability of y equals to
Yeah,
3.
ma'am.
Okay.
Y equal to 3. Sorry. What
So
is
y,
this representing?
okay. So y was representing. So first y was representing the number of particles counted during a time interval. Okay. So when the value of y is 3, it will represent that the number of particles which are being counted is 3
Okay.
in this time interval which are given. Fine.
Yes, ma'am.
So you all got it? Or any confusion?
I got it, ma'am.
Okay, fine. So now question number 3 is the number of items sold by an online store in an hour follows a Poisson distribution with lambda equals to 2. Find the probability that in the next 4 hours, exactly 3 items will be sold. So we have to find out the probability for exactly 3. Okay, if the random variable is x, then for x equals to 3, we have to find out the probability. Fine. You can see from the formula of Poisson distribution, we need to find out the value of lambda and y. Okay, so y or x, whatever you are taking as a representation, it is given as 3. Fine. You have to find out the
Yes.
value of lambda. Okay. So here the lambda is given as 2. And number of items sold by an online store in an hour. So this lambda will be for 1 hour only. Okay. So lambda equals to 2 means number of items, average number of items being sold in 1 hour will be 2. Okay. We
So
have
lambda
to
is 2.
lambda is 2. What lambda is representing, I am saying. Okay, lambda is representing here that average number of items that are being sold in 1 hour.
1
It
hour.
is
Yeah.
in 1 hour. 1 hour. It is 2. Fine.
Fine.
But we have to find out the probability that in the next 4 hours. So we have to calculate this lambda for 4 hours. So in 1 hour, it is 2.
4 hours will be
So
8.
4 hour will be 4 into 2.
Yes, ma'am.
8.
Okay, so okay, lambda dash will be 2 into 4. Fine.
So fine.
So it is the same as before. We have calculated the value of lambda dash. We know the value of y. Now you can solve it. Fine.
Yes, fine.
Okay.
The y here 3 factorial, right?
Y is 3.
Okay.
Yeah, y or x, you can take any random variable.
Okay. Thank you.
Now, question number 4. X is the number of occurrence of the Poisson variate with parameter lambda. Then you have to choose the correct option. Now think about it. What should be the correct answer? You are trying or no?
The first one seems to be correct.
Yeah, which one is correct?
The first one, I think, which you have written, ma'am, in the line.
Okay, let's check it. I have written the same or no? Just check it. N plus 1 and probability minus spread 1 equal to 1. Suppose we have this line. Okay, this is our n, this is our n plus 1. So according to this, it will include the probabilities n plus 1 and above this point. Fine. And it will be including the probability at n and above this point. Fine. Now, according to this statement, probability of n is this minus this. Don't you think it is opposite? It should be probability of x equals to n. It should be probability of x greater than equal to n minus probability of x greater than equal to n plus 1, I guess.
Oh, yes, ma'am.
Right?
Correct, ma'am.
So first option will not be correct. And if you think about the second option, it is x is greater than equal to n plus 1. It is greater than probability x is greater than equal to n minus probability of x equals to
Yeah,
n.
ma'am. This is what you have written, ma'am. They have just rearranged that
Hmm,
probability of x.
So this will be the correct option. Fine.
Option
Now
2
the
will be the correct option.
option 2 will be correct.
Yes, ma'am.
And option 3 is x is greater than equal to n plus 1. Then we have added the probability at n plus 1 and n greater than or equal to n plus 2. It is also correct, right?
Yeah, ma'am.
So n plus 1 is also included. So it is n plus 1 and greater than n plus 2, greater than n plus 1 means we will start from n plus 2 and we'll continue it after n plus 3, n plus 4, and so on. So option 2 and 3 will be correct.
Yes,
Fine.
ma'am.
Now the next question is the number of person arriving per hour in an insurance company for the insurance of their car follows the Poisson distribution with parameter 6. Find the probability that exactly 7 people will arrive during the 90-minute period. So the question is similar. We have solved it. You just need to find out the lambda again. Okay. It is asked for exactly 7 people. So if you're taking a random variable as x, then small x, you have to, small x will be 7. You have to find out the probability when capital X is taking the value 7. And you have to calculate the value of lambda or lambda dash, you can say.
Oh, ma'am. 1.5 times it will become. Because initially we have for 1 hour, now we need it for 90 minutes.
So what will be the lambda dash then?
1.5 times the original lambda.
Tell me the exact value, what will be the lambda dash or lambda, or whatever it is.
Uh, 6 into 1.9, ma'am, 9. Lambda is given to be 6. 1.5 into 6 is 9.
We are not audible.
Sorry, there was a network issue. That's why I got disconnected, I guess. Am I audible now?
Yes, ma'am.
No.
Oh, okay. Sorry for this inconvenience. So did you solve it? Simple. For 1 hour, it is 6 people. Sorry, yeah, 6 number of person arriving in 1 hour, or we can say in 60 minutes. So you have to find out for additional 30 minutes. It will be 6 divided by 2. So lambda will be 6 plus 6 divided by 2. it will be 9.
Yes.
Fine.
The screen not available. Screen not visible.
Screen, oh, sorry. Swati, are you there? Sharing.
Audible, not visible.
Actually, the sharing option is not there for me because I was disconnected with the meeting.
Hello.
Hello, Swati, are you there? Can you please
Audio
ask the
still-
team to please allow me to share the screen?
Okay, let me.
I'm not able to share my screen.
Just a second.
I got disconnected. I think that's what it's happening. By the way, you got
Now
that question?
Now you can share the screen.
Yes.
Yeah.
Available. Yeah, it's visible now.
Yeah, it's okay.
Hmm.
But it's all.
Solved. Fine.
Point 114.
Now. So the question is, suppose the random variable x follows Poisson distribution such that the value of expectation of x square is 6. And then we have to find out the value of expectation of x. You just simply use the formula of expectation of x and variance of x. You can find out these values. Fine.
Ma'am, for
Fine.
Poisson, the mean and variance are same.
Yeah.
That's what. Okay,
Hmm.
ma'am.
So expectation x and variance of x will be same. Lambda, just put these values of expectation of x square and you will get the value of lambda. Fine.
Yes, ma'am. Yes, ma'am.
Okay. Now, next is a manufacturing company produces medicine bottles. If it finds that the probability of producing 3 defective medicine bottle is 2/3 times probability of producing 4 defective medicine bottle. So, assuming the number of defective medicine bottles in the company follows the Poisson distribution, you have to answer this question. So, what you are given is according to the question, probability x equals to 3, it is equals to 2/3 times probability x equals to 4. Now you just need to put the values in the formula and you will get the value of lambda. Okay, so it will be e to the power minus lambda, lambda to the power lambda to the power 3 divided by 3 factorial. Okay, you can solve it or no?
Yes, ma'am.
Yes.
Yeah, it's very simple. You can solve it.
But they are okay. These are all straightforward.
Fine. So average number of defective medicine bottle, it will be the lambda. And standard deviation, variance will be same as the expected number. You just have to take square root of it.
Yes, ma'am.
So we
Square
can
root of
solve
it.
this also, I guess. Very simple.
Okay, ma'am.
Okay. Yeah, all the activities are done. Now practice assignment. You are given all the solutions. Any questions on this? Or I should
No,
explain
it's
or
fine.
so if you have any doubt in any question, just read it and ask me then.
Ma'am, question number 4.
Question number 4. Okay. Why it is showing week 11 tutorial 5 for me? This tutorial or practice assignment?
It's practice assignment questions.
Okay, fine. Question number 4 is the probability that a Python developer writes a line of code without any error is 0.98. He makes those errors randomly, making of an error in each line of code is independent of each other. He writes a code of 100 line. What is the probability that he makes exactly one error? So we have to find out the probability that he makes exactly one error. And the probability that the Python developer writes a line of code without any error is 0.98. So the probability for that the Python developer writes a line of code with error, you can find it by 1 minus 0.98. Fine?
Yeah, 0.02.
Okay. Okay. So, and statement is he makes those error randomly, making of an error in each line. So it is the example of binomial distribution, right?
Yeah, ma'am.
Okay. So you are given P. X is given as 1 and
100
N is
C1.
100.
Yeah,
Okay.
yeah, ma'am.
Okay, ma'am. Thank you.
Okay. Any other question?
Poisson distribution is lambda.
Sorry.
Poisson distribute is lambda. In Poisson distribution has na Poisson distribute. It means lambda. Value of lambda.
Which question?
Down.
This question 4.
No, ma'am. Down.
Okay. Question number
Ma'am, question number 7.
7. Okay. Suppose the number of visitors arriving at a zoo can be modeled to be Poisson distribution.
Lambda
in a-
na Poisson distribution.
Yeah, lambda is the parameter for the Poisson
Okay,
distribution.
ma'am. Thank you.
Any other doubt?
No, ma'am.
Yeah. Anyone else? Any other question?
No, ma'am.
Fine.
Yes, fine.
Okay. So should I close the session now?
Yes.
Okay. Thank you, everyone.